All right, so I just want to go over a few things about these electron configurations. All right, so this is the lowest energy. 1s is always going to be the lowest energy level. 7p would be the highest. And when we're filling the orbitals, we have to start with the lowest. So the first two are going to go in the 1s, and then we fill the 2s. If we have enough electrons to fill it and still more electrons, we go to the 2p, then the 3s, 3p, 4s, so forth and so on. Okay. Now this question is asking the valence electrons and which ones are the lowest energy valence electrons for lead. So the first thing you have to know is that the valence electrons are the outermost energy level. Okay, so each one of these rectangles is an energy level. This first energy level has one sublevel that can hold 2 electrons. The second energy level, that's why it's 2s and 2p, it has it has the 2s, and then the 2p has 3 sublevels that can each hold 2 electrons. Okay, and you keep going up. So lead here goes up to the 6p, right? So that means this 6th level of electrons, this 6th energy level, that's the valence electrons. And the lowest energy ones would be the 6s, right? Because the 4f are higher, the 5d are higher, and the 6p are higher. So the 6p would actually be the highest energy valence electrons. So with this, I wanted to show you, like here, radon is a noble gas. So on the periodic table, the noble gases are the ends of the periods. And so they're over here. These are the noble gases. And they're just a good place to start. So if I wanted to write the electron configuration for iron, I don't want to have to write out everything that came before iron. So I'm going to use the noble gas before iron, in this case argon, and then I just fill in what gets me to iron. This is just easier that way. All right, so to illustrate this, these are the noble gases. Helium is 1s2. It has one s orbital. It has 2 electrons in it. Neon is next. Notice we're adding the 2s2 and the 2p6. So these are the valence electrons for neon. All right, and then argon. Again, there's a repeat, and then we add the stuff that makes neon neon. And then krypton, there's repeat, and then we add. Xenon, a whole bunch of repeat, and we add the new stuff. Radon, a whole bunch of repeat, and we add the new stuff. So when they put radon here like this, it's just a shorthand way of saying we all know what leads up to radon, so I don't have to rewrite all that. Okay. Now when we work out radon, so radon gets us to 6p6, which is right here in berkelium, which is the element that has 97 as the atomic number. So that means everything after 6p6 would be 7s2 and 5f9. And that is not what is listed here, so this is a false statement. All right. So with these, they ask you to, which of the following is the correct off-balance diagram? And you had to draw something like this. And the key thing to remember is that phosphorus has atomic number 15, so it has 15 electrons. So we can easily fill up the 1s energy level. We can fill up the 2s energy level. With the 2p, we have to fill up 1 electron, 2 electron, 3 electron, and then go back and do 1, 2, 3 again for a total of 6. Then we fill up the 2s, and then when we get to the 3p, there's 1, 2, 3 left. So there's only 3 there, but we have to put 1 electron in each box before we double anything up. okay, per orbital, okay. So you should have something like that. This should say 3p, all right? And here, this is one that looks complicated because it's asking you to identify the element, and they give you this long configuration. But remember, the superscripts are the number of electrons. So you just add those up. And since it's a neutral atom, we know that protons equal electrons. So if it has 29 electrons, it has 29 protons, which means the atomic number is 29, which means it's copper. All right. Now, we did do some classwork practice. So before we did that, I introduced this yesterday, actually. This is kind of the quick, easier way to look at electron configurations. So the first thing we have to do is we have to put helium over here. And we're going to forget that, okay? And everything over here is the S block. This is the D block, the P block, and we have the F block down here. Now the electron configurations look complicated, but they're really just like a roadmap. So hydrogen is the first element, and it's in the first period. And so that's 1s1. It's in the big one, the coefficient means that it's in period 1. The S means it's over here in the S block, and the superscript 1 means it has 1 electron. Okay, so 1s1. Helium is also in period 1. It's in the S block, but it has 2 electrons. So it would be 1s2. Right? If we want to do lithium, we've got this whole period behind us, so that's 1s2, and we're going to add 2s1, right? Because that's that third electron. And beryllium would be 1s2, 2s2, because it's 1, 2. If we want to get over here to period 4, I'm sorry, not period 4, but group 13, then we've got boron, right? Now, so that means we've got the 1s2 behind us, the 2s2 behind us, and we're going to come over here to 2p1, right? And if we wanted to do, let's say, oxygen, we've got 1s2, 2s2, and then 2p1, 2, 3, 4. So it would be 2p4. Okay, so let's say we wanted to do magnesium right here. I'm sorry, manganese. All right, so we start with hydrogen, and period 1, so we're going to have 1s2. And then it takes up all of, in order to get to manganese, we got to go all the way across period 2. So that includes 2s2 right here, and then all 6 of the 2p, so 2p6. Then we're going to go down to period 3, so that's 3s1 and 3s2. And then we have 3p, right? This is period 3, and we're in the p block. 1, 2, 3, 4, 5, 6. So we're going to have 3s2 and 3p6. Now that brings us to period 4. We're getting closer to where we want to be. We've still got to go through these 4s, right? So we're going to have 4s2, and then we have to go 1, 2, 3, 4, 5 to get to manganese. And so that's going to be 4 D, because that's the D block, 5. And that's really all there is to it. So we're going to practice that. So what I want you to do on a piece of paper is you're going to do these. Now I included argon and krypton down here, so you can use those as noble gas cores if you so choose, so you don't have to write out all this stuff over and over again. But you still have to figure out which noble gas to use, and you have to figure out what comes after the noble gas. So work this out, and then you can show me Monday in class. All right? I hope this helps, and if it doesn't, please ask questions. Thank you, and have a nice day.